Okay, now we're in chapter 6. So this is 6.1, Exponents and Polynomials. It is page 67 of your workbook. So we have some rules and properties that we want to go over. You're probably a little familiar with exponents and how they work. So we have let a be a positive real number and n be any real number, then a to the n, where a is called the base and n is called the exponent. Okay, so this is called an exponential expression. We have a is our base and n is our exponent. A lot of times you might see it as b to the x, like that. Just variety of publishers or just situations and problems that we might use different letters, but that's fine as long as a is a positive real number. So we want that to be greater than 0. It's just part of the rule. We wouldn't have a negative in there. So when the directions state simplify, that means all exponents are positive. Each base occurs only once. There are no parentheses and there are no powers written to powers. Okay, so we need to really streamline it down. So for example, here we have 6.1, evaluate by expanding first. So first we're going to look at how we would stretch that out. And if we had 5, a base of 5 raised to the third power, that means we have 3 factors of 5. So that would look like 5 times 5 times 5. So make sure you're not doing 3 times 5, but it's 5 factors of 5, and that should be familiar to you. Then we have 5 to the 4th would be represented as 4 factors of 5. Now we could calculate that all out to equal a number. If you want to do that, go ahead and multiply that out. But there's definitely a quicker way. You would get 78,125, pretty big number. So we want to use exponents to help us with this. And now if we were to condense things down, those together, I still have a base of 5. These have to have like bases in order to use this process. We would have 1, 2, 3, 4, 5, 6, 7 factors of base 5. So we can develop a rule. What happened was we did our 5 to the 3rd plus 4th equals 5 to the 7th. And if you were to calculate them out separately, 5 to the 3rd would be 125. And we would multiply that times 5 to the 4th would be 625, and that would equal 70,125, same as 5 to the 7th. So this is a quick process, and we can develop a rule from that. What we want to be careful is that we have the like bases. So here's our rule right here. Let a be positive real number, n and m be any real numbers. Then a to the n times a to the m equals a to the n plus m. Okay, so here's a little note. We need to have like bases. So we're going to go through and I'll do a couple of these. I'll take maybe this one here, and then you could try the others on your own. Now I'm going to use my associate property to kind of get these coefficients to my variables out of the way. So I could regroup these as 2 times 4 times -3. Leave them off to the side. Then I have a base of x, and I can add my exponents up. If there's nothing there, it's understood to be a 1. So that's just 1 factor of x. So I would have 3 plus 2 plus 1. I would just calculate out my coefficients. I would multiply them as -24. I don't want to distribute anything over multiplication. I just, 2 times 4 times -3 is -24. Base of x stays as is, and I add those exponents up and I get 6 in my exponent. So that is my answer. Now the next, for A and C, I want you to do those as classwork and just try them, and then I'll fill in the answers. C is a little tricky, so think about it. You have to have your separate bases and kind of map them out. A you should be able to do, but you could try C as a classwork, or, do an example with me. I'll do it out. Okay, so the answer for C should be 10, A to the 12th, B to the 9th, C to the 4th. And if you got that, then you can just skip through this part and move on. That's awesome. If not, follow along with me. Again, I'm going to group these 5 times 2, these coefficients, and then I'm going to lay out my bases. So I have an A, I have a B, and I have a C. Now I have to look at the exponents attached to them. I'm going to be multiplying. Again, don't distribute anything. We only do that over plus or minus, and this is all multiplying. And this is the only case we can do the add exponent thing as well. So we have A to the 3rd times A to the 9th would be A to the 3 plus 9. I'm just going to leave it written out for now. And then B to the 7th times B squared would be B to the 7 plus 2. And then the C is just to the 4th. There's not one on the in the other parentheses. So now we have 10 times A to the 12th. Just add those exponents. B to the 9th, C to the 4th. And there we have it. And again, that is called the product rule for exponents. Now we're going to look at the quotient rule for exponents. And we can evaluate by expanding first. We have 4 to the 6th over 4 cubed. And you could calculate those out for each one. You could figure out what that's going to be. Like if you have 4 raised to the 6th power, you should be getting 4,096 on your calculator. And then 4 cubed. And make sure you do know how to calculate these on your calculator. You'd get 64. If I were to expand it out, I would get 4 times 4 times 4 times 4 times 4 times 4. I would have 6 factors of 4 over 3 factors of 4. And you can see what happens here. We would reduce anything common and be left with 4 times 4 times 4, and we would say that equals 4 cubed. So again, if I, in this case, subtract the exponents, so it's kind of a step down from what you're doing. If you're dividing the exponentials, you subtract the exponents, because division, after all, is just repeated subtraction. And if we calculate this out, the 4,096 divided by the 64, we get 64. And lo and behold, we will get 4 cubed, we figured that out earlier, is 64. So it does work. It will always work in every case. So that's our answer here, and it's the same as doing 4 to the 6 minus 3. So the thing that people need to be careful of with the quotient rule is their negative powers. So when you're subtracting and you have a negative exponent in a denominator, it gets tricky. For Math 95, we're not going to worry about that. But for Math 97, you guys have to really pay attention. So now we have our quotient rule for exponents. Let A be a positive real number and N and M be any real number. Then A to the N over A to the M equals A to the N minus M. Now we have to add a couple more things in here. We are going to make sure that everything's positive, which we already said for A. We also have to make sure we don't have a 0 in the denominator, and if we have a value, we're good. And then we also need to take into consideration the like bases. Again, it only works if we have like bases. So I'll do a couple, and you could pause at any time and try them. You could pause now and see if you can get them all done. So here I would have keep my base, subtract my exponents. I would get x to the 7 minus 4 over x cubed. Okay, so for b, I started with a to the 7th, b squared, all divided by a cubed b, and that's again to the first. So I kind of separate out my exponents to start with. I have a, and that would be 7 minus 3. Then I have a b, and that would be 2 minus 1. Now I can simplify that. A to the 4th, b to the 1, but I just keep it as b. Don't want to write it out with a 1 there. It's kind of considered choppy. Now here, if I have coefficients, it's the same kind of thing. I would separate those out first. So I'm going to leave the 8 over 6 off to the side, and then I can reduce that later. Then I have my m to the 7 minus 5, and my n to the 4 minus 1. Now 8 over 6 would reduce down to 4, if I divide by 2 over 2, right? I'm going to get 4 thirds, just leave it like that. And then I would have m squared n. And that would be my answer for that one. Let's make this box match. And that's called the quotient rule. Okay, the power rule gets a little more involved, and we're going to use the rules that we've already kind of created here, or, you know, they're standard, but we saw how they worked. So I'm going to do that in a separate video. So consider this one kind of introductory, probably maybe even review for you. So have a great day and check out the next